So in my level, I've got 2 clients and 1 server. I also have a minion character that is currently blocking by activating the block ability. So when my server attacks this minion actor, you can see that there are some particle effects being played, after which you can see a smoke effect. So basically I'm trying to play sparks during parry and play maybe a smoke effect during block, so that this can be a great visual feedback to understand if your attack has been parried or has been blocked. Beyond parry, we'll be performing the relevant visual effects and the animation during these disabled states. Like for example, there will be a particle effect like roots of a tree around my actor to indicate that he has been rooted in place, and also an animation that is being played on all machines. And as the root effect expires, I will be able to move, and also the root visual effect and the animation has ended. And as for the stun effect, I will show another different visual effect and a different animation, after which the visual effect and the animation ends as the stun effect ends. So gameplay cues are actually classes where we can perform any audiovisual effects. The GAS documentation project, in the README file, section 4.8 includes a lot of information on gameplay cues. Gameplay cues are invoked using a corresponding gameplay tag. These tags must have the mandatory parent name of gameplay cue. So technically, a simple gameplay cue might look like gameplay cue.a.b.c, where its compulsory parent tag is gameplay cue. So you could also have gameplay cue tags such as gameplay cue.damage.fire or gameplay cue.damage.electricity, and so on. So there are 2 classes of gameplay cues. One is called the gameplay cue notify static. The other is gameplay cue notify actor. Gameplay cue notify static operate on the CDO or the class default object, meaning it actually operates like a static class. And this can be great for one-off effects like maybe bullet impacts, sword impacts, and other such small effects. Whereas the gameplay cue notify actor is actually instantiated as an object in the level. These gameplay cues behave just like actors in a level. These are great for more complex gameplay cues, like maybe looping sounds and other particle effects, which are usually used for duration or infinite gameplay effects. Like for example, if your target is on fire for a particular duration or indefinitely and must also emit the fire sound in a loop. Gameplay cues are also replicated by default, that is, each gameplay cue is actually a multicast remote procedure call that is an RPC on all machines. So this can cause a lot of RPCs over the network, and so you should be careful about where to use these cues because of its heavy use of RPC. So it would be preferable to use gameplay cues locally where you can. For example, projectile impacts, melee sword impacts, and other gameplay cues fired from animations. We'll be learning about gameplay cue static. So in my project's base folder, in the ability system folder, I have created a folder called cues, within which I have created 3 folders for the different ability cues that I have implemented in my project, namely root and stun. In the parry folder, I have the relevant assets for the visual effects of parry, and I also have a blueprint class called GCS parry, which stands for gameplay cue static parry. Although that is where I've implemented the parry cue, for this demonstration, I shall create a new blueprint class. So choose the static class in the all classes section. I shall rename this to GPQ static parry. Now, this gameplay queue static parry class has pretty much two properties in the gameplay queue category. The first one being gameplay queue tag that notifies this queue's activation, and secondly is override, where it is used to specify if we wish to actually override another gameplay queue of this tag's parent. We shall now provide a gameplay queue tag for our static parry gameplay queue, and you will notice that while adding a gameplay tag, we only have a parent gameplay queue and no other tags in our project. So the editor only shows tags under gameplay queue, which I have already created using an external JSON source file. You'll notice that we have about 5 functions we can implement. We shall implement the onExecute method. This method will be executed during the effect executions of instant or periodic effects, and not during their application. That is, if your effect has a periodic tick of 0.5, maybe during a DPS, then this method will be executed every 0.5 seconds. So during the implementation of this method, I will just make sure to include the parent onExecute node. I shall use only a simple print log parry, and in here, my target is the target of this effect. So after having implemented the onExecute method, make sure to specify the relevant gameplay queue tag. Under the gameplay queue parent, I shall add a subtag test, under which I shall use parry. So in our parry effect, in the ability system effects and block directory, if you scroll down the effect class and in the display category, we have the gameplay queues property. So gameplay queues are specified as an array. So this effect technically can invoke more than one gameplay queue. I have specified the first and only gameplay queue, which has magnitude attribute, minimum level, maximum level, and gameplay queue tags. So technically, we can choose all the relevant gameplay queues to play during this effect. I really wish I could have referenced an Unreal Engine asset here, but this is just how gameplay queues in GAS work, and you do need to use tags. I shall specify my gameplay queue.test.parry tag and remove the gameplay queue.parry tag. And so now, in my level, let me walk up to the minion while he's blocking, and you can see that the block effect has been applied, consequently invoking our gameplay queue test.parry. So you can notice that gameplay queues are technically multicast remote procedure calls on every machine. Now after having printed the log message, it's now time to show the visual effects. I shall be using the spawn emitter at location method. The parameter emitter template requires a particle system object reference, and it allows you to choose many particle systems in your project. So in the Paragon Steel folder, I shall search for shield sparks. So this is the asset I wish to use. I shall drag and drop this asset and click on copy here into my directory base, ability system, queues, and parry. I shall rename this to new parry sparks, and I shall now add the new parry sparks into the emitter template parameter. Also make sure to connect the myTarget to the world context object. It's a required parameter for the spawn emitter at location method. So from myTarget, I should get the actor location and pass that into the location parameter, and that's it. That's all is needed to spawn an emitter particle system into the level at that location. So in my level, when the server now attacks the minion, since the minion has parried, that is, it has an active parry window through that duration effect. So my target is actually the parried melee attacker itself. This sparks is spawned at the location of the melee attacking actor. Now we can modify more parameters to our particle system to our liking. I felt the sparks were too small and too short-lived. In this new parry sparks asset, there are 3 emitter assets. I shall first modify sparks, where the sparks is dying out too quickly and I want to increase its duration. So in the lifetime parameter, I can change the lifetime duration. This lifetime duration follows a distribution curve, which has a set minimum and a maximum value. This is actually the seconds of the lifetime of the sparks emitter. If I change 0.35 to 10 seconds, you'll notice that this emitter will play for 10 seconds and the spark will stay for the lifetime of 10 seconds. And 10 seconds seems to be pretty long, so I shall change that to 3. So 3 seconds is looking good. As for the main flames emitter, which actually shows some kind of a flame in the center of this particle system, I shall set the lifetimes distribution curve's max value to 0.2, and even the flare small bright emitter, I shall change its lifetimes duration curve's maximum to 1 second. After having modified the lifetime duration of the different emitters of this sparks particle system, the sparks emitter was also too small, and I shall increase its size using this scale parameter. I shall set the value of 3,3,3 for the XYZ of the scale parameter, and so the sparks is pretty much tripled in size. So this time in my level, the spark appears bigger, and the sparks are also lingering as a visual effects for a higher duration. So since this parry queue is called by the block and parry effect, we should also work on the case where we are applying an effect on the minion target during block. So I already have an asset here called block flames, which is what I want to use. This block flames particle system is also from the Paragon Steel directory, that is Shield Solar. So the Shield Solar particle system looks like this, where there's like a fiery impact, and I think it's a great particle system to use for block. So in the onExecute method, I shall add a sequence node. The last step will be to return, of course, and so I shall use an if node. So this if is going to verify if we are blocking or not. That can be verified by getting the target's ability system component and calling the method has matching gameplay tag. The tag to check will be combat.block. And so if my target's ability system component has the matching gameplay tag combat.block, then I shall spawn the emitter parry sparks at the target's actor location, which in the case of block is actually the damage receiving minion actor. So I shall copy these nodes for the false condition where if the target is not blocking, the target has parried, for which my target is the attacking melee actor blueprint hero. So for the parry spawn emitter at location method, I shall use the block flames particle system in the emitter template. And of course, I shall connect the world context object to my target. The scale will also be set to 1,1,0. And also, I almost forgot to show you in the minion class in the begin play, I'm performing the block ability after about a delay of 2 seconds. This block ability is found from the initial ability container property, which for the minion class has already been configured with 2 abilities, the melee and the block. So after about 2 seconds, when the minion has spawned, it shall perform the block ability. And in that manner, you can actually invoke many abilities for your AI controlled characters. So in my level, when the server attacks the minion during the parry window, you'll notice that the block flames emitter is being played. And when the parry window expires, the sparks emitter is being played. So in that manner, you can actually show visual effects for parry and block, maybe as in Sekiro. And in this manner, a single gameplay queue static class can be used to handle both block and parry. And in this gameplay queue, we only implemented the onExecute method, but we do have other events to handle a gameplay queue. So in the functions category, you'll notice that there are 4 other overridable methods. The handle gameplay queue is a method that is pretty much called for every event type. So in this method, you have the event type parameter, which is of the enumeration gameplay queue event. And this can be switched to handle the other 4 events on active, while active, executed, and removed. So it can be one centralized place where even your executes operation could have been written. OnActive method is used to handle the event where a duration effect is first activated, that is, when it is just applied. The onRemove method is called during the event where the gameplay cue under a duration effect is removed. And the whileActive method is called when a duration effect is first seen as active. So, as part of your further reading, you can check out the GASDocumentation project's README file. The section 4.8.8 talks about these gameplay queue events. In the third step, we'll be learning about gameplay queue notify actors. In the ability system and queues folder, I have 3 folders. I've also created the root and stun folders where I'll be implementing the gameplay queue notify actors. Let's start with the stun method. In the stun folder, I already have a gameplay queue actor, GCA stun. But for this demonstration, I shall be creating a new gameplay queue actor class. So in the all classes, I'll search for gameplay queue. And unlike the last time where I selected static, this time I'll be using notify actor. I shall name this GC actor stun. And so you'll notice that this class has a viewport, unlike the gameplay queue static. Technically, we can add scene components. We also have a components panel. Thirdly, in the event graph, you can see blueprint events, begin play, actor begin overlap, and event tick. And fourthly, in the My Blueprint panel, in the functions category, you'll see that we have 24 overridable methods. So technically, the gameplay queue notify actor is inheriting from the actor class. The actor class exists in the GCA's parent hierarchy. So in this gameplay queue actor class, we're going to be overriding these methods that were declared in the gameplay queue notify actor class. You'll notice that these are the same methods as we saw in the gameplay queue static. I shall override the method onActive this time and not onExecute, which, as I had mentioned, is invoked at the time of application or an activation of an effect. So I have the same parameters, and in this method we shall print a simple log message. Similarly, I will be implementing the onRemove method, which is actually invoked when the gameplay effect calling this gameplay queue has been removed. So even in this method, I shall print a log message stun removed. In the onActive method, we'll change the text color to maybe dark green with the message stun active. And in the class defaults, you'll notice that there are properties, just like the properties of an Unreal Engine actor. So this GCA literally behaves like an actor that can actually tick. We can also utilize the ticking of this actor. And so if I scroll down, you will see there's a gameplay queue category. In the gameplay queue tag property, I shall provide a tag gameplay queue.test.stun. I'll also select the auto attach to owner, which is a property unique to this actor gameplay queue, where it attaches this gameplay queue actor to its owner actor. I shall also keep the isOverride property to true. And now let's test this gameplay queue actor class. In the ability system, effects, and disables folder, in the gameplay effect stun, I'll scroll down to the gameplay queues category. And in here, in the gameplay queue tags, I shall provide the tag gameplay queue.test.stun. So in my level, the server actor walks into that volume of effect, the ball drops, and I have applied the stun gameplay effect. You can see the printed log message on all machines. That means the onActive method was invoked by this duration gameplay effect stun. So now it's time to show some visual effects in this gameplay queue actor. In the components panel, under the default scene root, I shall add a new scene component, that is the particle emitter cascade particle system. You can pretty much add any scene component to this because it literally just behaves like an actor, and this becomes the root scene component. We have a template property of this particle system under the particles category, and I shall use the particle smoke, which is part of the Unreal Engine starter content. So now, in the viewport, you can see the smoke particle system being played. So this being the scene component is what this actor will look like in the level. So this means no need to spawn an emitter as we did in the gameplay queue static. So again, in my level, I shall attempt to get stunned, and you'll notice that stun active has been printed, and this actor is now emitting a smoke. And this smoke emitter is attached to this actor and even rotates as this character rotates. So this means the gameplay queue actor has been spawned in the level. So you can notice that despite the removal of the effect, this smoke particle system is still attached and active onto my character. So yeah, for this example, I used smoke for the stun particle system. Maybe you could use a better stun particle system in your game. So technically, we do need to deactivate the particle system as the effect ends. I have also implemented the gameplay queue actor for the root disable. So in my queues and root folder, in the GCA root, I have implemented the onActive and onRemove methods. So in order to prevent our particle system from existing even after the effect's expiry, we should activate or deactivate the particle system component. The root scene component looks like this, where it looks like a vine or the root of a plant. This root particle system was obtained from the Paragons asset for the Faye character, and in this character, I'm using the ultimate tethered particle system. And so I copied this particle system into my ability system queues and root folder. In the onActive method, first I shall activate the particle system component object. So this particle system can activate only when this gameplay queue activates. And in the onRemoved method, I'll only be deactivating this particle system. And so this particle system will be activated only if this gameplay queue actor is activated. So you'll notice that I do have my particle system attached to this character while he has been rooted. And when the root ends, that particle system is deactivated. It is now time to play the animations for these gameplay cues, that is the stun and the root disables. In my onActive method, I shall remove the print string and attempt to play an anim montage. For this, I shall cast the myTarget actor to a character object and call the character object's playAnimMontage method. I have already procured the animations for the stun and root disables. In my base folders, assets and animations folder, I have a disables folder within which I have all of the animation assets for all of the disables. So for the stun gameplay queue, I shall use this stun montage. My mannequin will look like this during stun, and this animation was found in the Paragon Gideon folder. I shall copy that animation sequence into my disables folder. I shall replace this animation sequence skeleton to the SK mannequin skeleton, and now you can see that the mannequin is doing that animation. To this animation sequence, I shall create an anim montage. I wish to play this animation on a loop, so I shall check the option to set loop to true, and also make sure that the montage section loops to its default section after the completion of this animation. I shall delete these assets because I've already procured my stun montage, and I shall use this montage in the gameplay queue class. And that's all there is to this method really. You can take advantage of this multicast RPC since queues are replicated by default, and you can play animations on all machines because these are also not gameplay driving animations, rather animations only for visual cues and a visual feedback. And in my onRemove method, I shall attempt to stop the anim montage. So I shall cast the myTargetActor to a character object and call its stopAnimMontage method. The anim montage in question will be the same stun montage, and I shall connect this to the return node. So that's all really it takes to play an animation through queues. So in my level, I shall attempt to get stunned, and now you can see that I'm playing the animation, and also the gameplay queue actor stun has been spawned in the level. So you can see that our stun animation is being played. I may have forgotten to deactivate the particle system. So if you are following along, you may deactivate or activate this particle system in the stun gameplay queue actor, as we did in the gameplay queue root. Similarly, for the root gameplay queue, I have procured my own animations. I will be playing this root 2 montage. This montage has been made to loop within the default section after its completion, and also the loop property set to true. This montage was created from the Paragon assets steel character in the Paragon steel directory. You can search for steel recall loop. And I have replaced that skeleton with the Unreal Engine mannequin and created the anim montage. Initially, before the recording of this video, I was using this animation for root, and it looks quite funny. This was part of the Paragon assets Fey character. In the Paragon Fey directory, I found this stunned loop animation sequence. So in my queues root directory, in the gameplay queue actor root, I shall now play the animation in the onActive method, where I'll just cast to character and play the root 2 montage. Similarly, in the onRemove method, I shall cast the target actor to character and call its stopAnimMontage method and select the root montage. I shall hook this to my sequence node, and so now in my level, I shall walk into this volume of effect, and you'll notice that I'm playing the animation, and also the gameplay queue actor has spawned, where its root scene component, the particle system, is activated and visible. And when my root effect ends, technically the onRemoved method has been invoked, so the particle system has been deactivated, and also the root anim montage has been stopped. So this is really a great place to be playing animations that can serve as a visual feedback. And this parameters argument is actually a structure of the type gameplay queue parameters. It contains a lot of properties. We also have a location property, which can be used to understand the direction of the queue and effect, and that could potentially be used for maybe your hit direction animation, which could happen in 4 or 8 different directions. But these parameters can't be sent from an effect. Some information can be packaged into the effect context, and so beyond effects, queues can also be invoked externally through some events and methods. So in the GASDocumentation's README file, section 4.8.2 is the triggering gameplay queues section. It states that the gameplay ability class actually has blueprint methods to execute, add, or remove gameplay queues. So it's really convenient where you could do that in the gameplay ability class and also provide the gameplay queue parameters. This could be used maybe while casting a spell or something. So we get methods like add gameplay queue to owner, remove gameplay queue from owner, execute gameplay queue on owner, and also add gameplay queue with parameters to owner, as well as execute gameplay queue with parameters on owner, where the relevant gameplay queue parameters can be packaged. So this would be a great place where you could play some animation maybe before casting a spell or something. Like a character's hand would be covered in fire or water before they spawn a fireball. And in C++, you have the relevant methods directly on the ability system component class. And if you wish to, you can also create a subclass of the ability system component and expose these C++ functions to blueprints. So in this manner, we have been able to implement gameplay cues into our GAS project. I shall summarize the steps in reverse. In the first step, we learned that all these cues have to be invoked using gameplay tags. These cues can be invoked in effects at the time of their application, execution, or removal. And so in my stun gameplay effect class, in the gameplay cues property, I have added an element where the gameplay cue tags includes the gameplay cue for stun. Similarly, I've used the gameplay cue.root for the gameplay cue tags in my gameplay effect roots gameplay cues property. And in my block and parry gameplay effect, in the gameplay cues, I have used the gameplay cue tag gameplay cue.test.parry, which is what has been used for the static gameplay cue parry. We also learned the use cases of these gameplay cues, where they're used and when they're used. Gameplay cue statics are good for just one-off effects like hit impacts for a bullet or a melee weapon, whereas gameplay cue actors are good for looping events like looping animations, looping sounds, and maybe particle effects. We learned that these gameplay cues are replicated by default. That is, each gameplay cue event is actually a multicast remote procedure call. It's being invoked on every machine in that session. So this can cause a lot of RPCs, and so we should try to use local gameplay cues where we can. That is, during simple projectile impacts, bullet impacts, melee weapon impacts. In the second step, we implemented the gameplay cue static for the block and parry. Even in these classes, you could play animations if you'd like maybe a hit reaction using the location from the gameplay cue parameters. We learned that these static gameplay cues are nothing but static classes and not instantiated. They operate on the class default object, the CDO. It has only two properties, the gameplay cue tag and isOverride, where isOverride means this gameplay cue's lowest level tag in the tag hierarchy overrides every other cue in its upper level tag hierarchy. That is, maybe damage.magic.fire will override damage.magic. We have implemented its onExecute method, which is actually the method called whenever the effect is executing the modifying operation, that is, in an instant or the periodic intervals of an effect. We have handled both parry and block in this gameplay cue, where if the target's ability system component has the matching gameplay tag combat.block, then I shall play a spark emitter at this target actor's location, whereas if it does not have the tag combat.block, it is actually in the parry state within the parry window, and so we shall play the flames emitter at the target actor's location. So this cue is always called by the effect applied during block and parry, as done in topic 2.3. So yes, unlike the gameplay cue actor, you will need to call a spawn emitter method in such gameplay cue static classes. In the third step, we learned about the gameplay cue notify actor itself, where we understood its properties and methods. We learned that we can override both the actor methods and the gameplay cue notify actor methods. We implemented the onActive method, which is actually invoked when a gameplay effect is activated or applied, usually during the duration or an infinite gameplay effect. And the onRemoved method is executed when this duration or infinite effect is removed. And neither of these methods are invoked during the instant or periodic executions of the effect calling this gameplay cue. We also use the relevant gameplay cue tag, which is what is used to invoke and perform these gameplay cues. We also auto-attached this gameplay cue actor to the owner so that this scene component is attached to the scene component of its owner actor, and so it follows and stays on the character and even rotates. We learn to play animations in the gameplay queue classes of our stun and root disables. In the onRemove method, we stopped an anim montage and also deactivated the particle system, whereas in the onActive method, we played the anim montage and also activated the particle system. And this particle system is nothing but the root scene component of this gameplay queue notify actor class. So yes, just like any actor in an Unreal Engine level, gameplay queue notify actors do have scene components and can be instantiated in the level. These actors can also tick like any other actor. So that is all for this topic. I hope this topic has been informative and you can utilize this in any of your future projects. Thank you for watching and see you in the next one.